1 minus x squared all times by dy dx plus 3xy equals x squared. It's not in standard form. We need to get it to be so. So divide by 1 minus x squared then all the way through. That will give dy dx is here. So that's what's left when you divide by 1 minus x squared. Plus 3x over 1 minus x squared times the y is equal to x squared over 1 minus x squared. There we are. Now it's in standard form, we can circle the p. So let's do that then to make it absolutely clear what we're dealing with. Here's the p, so we know the integrating factor now. So here, the integrating factor then, e to the integral p dx, which is this, 3x over 1 minus x squared dx, which equals e to the integral. Now, I know that this differentiates to minus 2x, so I'm going to put the 3 there, and I'm going to write minus 2x there, over 1 minus x squared dx. Now, I can't change the number, the 3 here, so I'm going to have to put a minus 2 underneath, so I'll do that like so. So that will cancel with the minus 2 that I've just magicked up here, so that I haven't changed anything. Now this thing differentiates to minus 2x, so this is just the log. So we end up with then, I'll give myself a bit more room, e to the minus 3 over 2 ln of 1 minus x squared. So that's good. So we've done the integration then, because that's the log of this. If you differentiate the log, you get 1 over something, multiplied by the something differentiated, which is minus 2x. So that's fine, because that differentiates to that with the minus 3 over 2 lots of here. Now we need to get that out of the way so that we can get rid of the e in the log. Properties of logs, that just jumps up, doesn't it, to here. So e to the log of 1 minus x squared. And then this minus 3 over 2 can come up to be a power up there, properties of logs. So we end up with then equal to the e in the log now cancel, and we get 1 minus x, if I can write it correctly, sorry, 1 minus x squared to the power 3 over minus 3 over 2, isn't it? There we go. There's our integrating factor. So multiplied by the integrating factor all the way through then. So here was our original equation. So original problem. 1 minus x squared there to the 3 over 2 with a minus dy dx. And then times it here, we'll get the 3x there. The y can stay there. When you times by minus 3 over 2, it's like putting it underneath to be with the power 1 that's already there. And you add the powers. So 3 over 2 plus 1 is 5 over 2. X squared to the 5 over 2. And then that equals 2. And then looking on the other side, we're going to have x squared over. And it's going to be, that's a power 1. And we're timesing by 3 minus 3 over 2. So again, it's the same thing, isn't it? It'll be 1 minus x squared. One minus x squared to the 5 over 2, isn't it? As before. As just in the previous term. So that's what we've got then. So now we can look at this. Circle the u and the v. This is the u. And this is the v. So we can simply write here d by dx then of u times v. 1 minus x squared to the minus 3 over 2 times the y is equal to x squared over 1 minus x squared to the 5 over 2. So integrating then gives, well, the integral of the derivative is just the object itself, to the minus 3 over 2 times y. And then we've got the integral of x squared times 1 minus x squared to the 5 over 2. dx, which doesn't look very nice. But that's the problem we've got. So this looks like an integration by parts, with one of the constituents being a function of a function. So let's do that problem then. So what have we got? How can we write this to see that? Well, here I can write an x there, and here I can write a minus 2x, right? Because I need the minus 2, because when you differentiate the something, you'll get a minus 2. So I'll put that there for now. And I've got 1 minus x squared to the 5 over 2 dx. But I can't just magic up a minus 2, so I'm going to have to put minus a half here, like so, to cancel with that minus 2. Now I can see that that can be integrated. So I can label this as v, and this is du, and do parts. So that's equal to then minus a half, outside everything, u times v, so that's x times what this integrates to, which is 1 minus x squared to the minus 3 over 2. So let's just differentiate this to get the constant. The minus 3 over 2 comes down here, this to the 1 less, which gives us this, multiplied by the something differentiated, which is this. The only problem is the minus 3 over 2 term. We need to take care of that with a minus 2 over 3. There we are. That's the u times v minus the integral of u, which is going to be this thing here. So minus 2/3 will be 2/3 there. This will be 1 over 1 minus x squared to the 3 over 2 dx times dv, u dv, which is 1, which doesn't change it. So that's what we get then, which is not very nice at all. So we get minus a half, yucky do, minus 2x over 3, 1 minus x squared to the minus 3 over 2, plus 2/3. Now this, if I did a sign here, x equals sine u, 1 minus sine squared is cos squared, and that would be cos u, cos cubed, and then I might have a sign up above. So let's do that then. So we'll do u equals sine x, try that, and we'll have integral of 1 minus sine squared, x equals sine u, get it right in a minute. Let x equals sine u in this, so we're going to have 1 over 1 minus u squared, 1 minus sine squared, which is cos squared as we said. Cos squared to the half is cos, and it'll be cos cubed u, and then du dx, dx du is cos u, and that's du. So that's equal to then, close the bracket at the end, minus a half, minus 2x over 3, and I'm going to bring this down now, 1 minus x squared to the 3 over 2, plus 2 over 3. Now we've got a cos u and a cos u. 1 over cos squared is sec squared u. So that's sec squared u du, which is tan u, isn't it? Integral of sec squared is tan. So let's expand the bracket at the same time. This will be plus. The 2's will cancel. We'll get x over 3, 1 minus x squared to the 3 over 2, plus 2/3, and tan, isn't it? Tan of u, and we know that u is sine to the minus 1 of x. So put that in at the end there, plus a k at the end. So I think that'll do for our terms. What did we get at the top? Y, what was it on the left? It was 1 minus x squared to the minus 3 over 2. So let's times through by that then. 1 minus x squared to the 3 over 2. Let's do that. So y equals then, times in by 1 minus x squared to the 3 over 2, we just get x over 3, plus 2/3, tan of sine to the minus 1x, and then we're timesing by 1 minus x squared. 3 over 2. Bit of a rigmarole, that one, wasn't it? But I think we got there in the end with the explicit solution. Plus k, wasn't it? Sorry. And it would be 1 minus x squared to the 3 over 2. There we go.